Hello.
Hey, how's it going? How you doing?
Uh, Fine. You?
I'm doing okay. Sorry, I'm getting things set up here. Good to see you guys.
I
Today I'm going
I little know English. Sorry.
a little English. Okay, not a problem, buddy. Well, today I'm going to be working on a MySQL API for Flutter and Dart. So I'm going to reach out to a MySQL database, try to bring in some information back. You know, when building a database, it's always good to go and design your database first. So in this case, what I did is I went ahead and wrote down the database diagram. Let's bring it up. Let's see here, drag it on over. And of course, what do we always do when we first check? When we first start coding, we make sure that we are recent, that we have the most recent push. And we do. And what are these changes? Oh, this is the Mac OS build. So we need to, so here we are building it. Make sure our code compiles, it codes. We're going to come over here. We're going to work on this area right here today. We're going to be working on the prayer requests. Now, what's a prayer request? It's nothing more than someone reaches out and says, hey, I got I have this going on in life and I would like people to pray for me. Well, that's going to appear at the top of this here as people are going to push that down for a little while and they're going to pray for it. And then the person is going to get that message and it's going to be received prayers down here. These are what you have requested and these are other people's prayers. Whenever you click on one of these here, it's going to highlight and information will blow up here. All right, that's a quick breakdown. But to do all this, we need data because right now they're just blank. So the front end guy has built me this kind of theme of what I want. And so now I need to start getting the data to it. So to get data, we're going to look at this guy here. This is the database. This is what's going to be holding all of that information. So we're going to have a prayer request table. That prayer request table is going to be, the primary key is going to be the request key, followed by all this information. Let's see, we had someone else just join in. Hey guys, how's it?
It's beautiful.
It's beautiful, thank you. Hey guys, how's it going?
You're
Good to see
welcome.
you.
That's great. Good luck.
Good luck, Umit and Shrinbash and Cranberry. Good to see you guys.
We also start to learn Flutter.
You're starting to. Oh, this is a place to do it, man. I tell you, this is it's a great programming language. It runs on all platforms. It's a huge community. If you want to learn Flutter, then just sticking around these channels here will definitely be a bonus. Will help you out. All right. So then
I started Flutter.
you started.
I am very happy.
I'm very happy for you too. I hope you did you make
It
a
is
Flutter
beautiful
program?
technologies.
It is. Yes, sir. It is.
It is amazing.
It is amazing. Did you make a app? Did you compile an app?
No.
Not yet. Okay. Well, good luck when you do compile one.
Thanks.
I did.
You did? What did you make?
I am cloning Discord.
You're calling it Discord? Okay.
I'm doing my own Discord.
Oh, you're making your own Discord. Very nice. That's pretty neat, Umit. And is that how you pronounce it, Umit?
Yeah.
Oh, okay. Or is it Cranberry that's making the Discord?
Mm-hmm.
Oh, Cranberry. Okay, congratulations.
Thank you.
And so what I'm discussing right now one second.
Okay.
I'm streaming this, by the way. So this is on Twitch if you guys want to see it. Here, I'll post the channel just for you. https://twitch.tv myfluttercode. So you guys are on Twitch right now. All right. So as I was saying, this database has 3 tables in it. The prayer request table, that's you, your prayer request. The prayer request likes table, that's going to be a table that's going to have all the likes. So if people like your prayer, we're calling it a like, it's an actual heart. You know, if someone notices your prayer and says, "Hey, I'm thinking about you," you know, they can give you a heart. And then the prayer request prayed table is if the prayer request has been prayed or not. But you know what I just realized we're missing? What are we missing? We are missing so we have the prayer request likes table. We are missing a prayer request prayed table.
I think TSQL is the best SQL technologies.
TSQL?
I think,
I use MySQL.
in my opinion.
Yeah, I use MySQL. So the prayer request table is going to hold the prayer requests for people that have already prayed. Now, we are looking at a backend for this database. Let's take a look at the database. So for this, I use technology software tool called SQLite Flow, because what does Flutter and Dart use? Flutter and Dart uses SQLite. Why do we use SQLite? Umit or Cranberry, do you know why we use SQLite?
I use TSQL or Microsoft SQL.
Okay,
I don't use SQLite.
Okay, how about you,
We
Cranberry?
use SQLite, I guess, because it's built-in. Right.
Exactly, Cranberry. We use SQLite because it is built into all of your phone systems. So it's already there for you to use. So you don't have to bundle a MySQL client. You don't have to bundle some type of SQL system. It's already in Android. It's already in iPhone. It's already on Microsoft Windows. It's already on Linux. It's already on Mac. So it's already there. So SQLite is on all those systems. Why invent the wheel? You know, just use SQLite and then understand how to implement it on those systems. This is not an SQLite class, but I will show you right after I show you this table. I will show you how I implement it in my program once we start getting into the API. Okay, so we're going to open the
After
data.
that, I love SQLite.
What about SQLite?
SQLite is database technologies.
Yes, it is. It's RDBMS, Random Database Management System.
Yeah.
So here we have the tables, and we'll look at just the table schema. So this is everything that I was just explaining on this chart here. All of this minus this.
PostgreSQL or Microsoft TSQL, and yeah.
Microsoft TSQL, okay, but how are you going to get that? How are you going to bundle that in your program? So if you're using that, and let's say you make a running app, how are you going to put your database into that program and share your database? Because it's a MySQL or it's a Windows database, right? How is that Windows database going to run on an Android phone? How's it going to run on an iOS phone? How's it going to run on a Mac or a Linux system? It's basically, you're limiting it just to a Windows program. So when you design your Flutter or Dart
You
app,
are right.
yep, when you design your Flutter or Dart app, you want to keep in mind that it is a open platform system. Flutter and Dart can run on every system. This program that I'm running right now, this Bible Breeze, this is desktop version of Mac OS. You want to see something else? let's see, this is, let's show you, let's start an iPhone up. Let's start up an iPhone 14. It's going to take it a little minute, but here's the iPhone 14. It's firing up. It's just an emulator of an iPhone 14, of course. But we're going to compile and we're going to start this up on an iPhone. And then we can compile and start it up on a website. And then we can compile and start it up on an Android. Then if we were on Windows, we can compile and start it on Windows Desktop or Linux, because it's language designed to run on all of those systems. So if you want to take advantage of it running on all of those systems, you just need to understand the kind of the underlying isms of it. One of the mechanisms of it is that SQLite is a database, RDBMS, that is available on all of these platforms already. So if you use SQLite in your application, you'll be able to use it on all these platforms. Now, SQLite is just the program. There's other things. I myself use this technology called Drift. Now, Drift is a I forgot the name of it. Let's see. Let's not get rid of our music. Let's pull up Drift.
Do you have any API?
Yeah, I'm working on the API right now. That's what this today is. So Drift is a reactive library to store relation in Dart and Flutter applications. Drift is a way to talk to SQLite, and in a very easy to understand way, you know. So get ID, integer, get this, to do this, this is the language to talk to the SQLite instead of using direct SQL and using raw functionality. This gives you a, I don't want to say cocoon, this gives you a shell that allows you to access SQLite in a different manner. And to do that, this right here, this little last part is what you do to get it to run on your systems. So this here will allow you to run it on, Windows. It'll allow you to run it on Mac. It'll allow you to run it on Linux, just by going in and setting up your native database, your memory here. Now to do that, as I mentioned, I would show you where that is, and that is in my app. Let's see, application, data, mobile, right here. Right here is where all the magic happens. This is where the database is determined. If it's on Windows, it's going to do this information here. If it's on an iOS, if it's on iPhone or Android, it's going to do this. And if it's on Mac or Linux, it's going to do this. So these are the three types of platforms that it can be on. And that's all there is to it. I'm not doing anything else. I'm not creating a new database. I'm not creating multiple databases. As you see, every single one of them is using the Bible Breeze database that's in Assets. And that database, again, is this SQLite database right here. That's it. You do one SQLite database and it ships with your product, and it can be run on all of these systems. What's really nice too is it can also be run on the web. If you use that Drift program I was talking about, if you use Drift allows you to use SQLite on the web. It's pretty neat. Okay, so I said I would show you this on iPhone. Let's go ahead and run it on iPhone. All right. So next we have the database, right? Now we have the database locally. Do we need the database locally? Not really. What do we need this here for? Maybe if we want to cache the data in the future, we can have it here, but we don't need it here. Where do we need it? We need it on our database that we're going to be calling from, because this is a remote system. So we're not pulling data from, if someone, clicked a like on it, we don't know that they clicked a like, because this is our local database. We need a remote database. That's what we're doing today. So let's look over at, I don't remember where it is. Let me look real quick where my database is. Database.
Bir şeye bakar mısın Özel?
There it is. So let's see our database. I use PHP MyAdmin to access my database. Let me put in my username and password, and then I'll bring it up. You can't see my username and password. Super secret.
We use ASP.NET Core for backend.
ASP?
Yeah.
Have you? I haven't. No. Is it any good?
Yeah, we love it.
You love it. Can you use it on Flutter and Dart?
Yep, of course.
And you use it for the websites and Microsoft products, right?
It's also cross-platform, so you can run your ASP.NET Core projects on a Linux server.
Really? I did not know that. Can you use it on Macintosh and iPhone and Android also?
Yeah.
Really? Well, I don't want to go off on a tangent. As I say, I'm streaming how to do APIs right now, but let's go off on a tangent. Let's look. ASP cross-platform. Explain.
ASP.NET Core, yes.
.NET.
ASP.NET
Core
is an open source web framework created by Microsoft for building modern web apps and services with .NET, apps.NET. Cross-platforms run on Linux, Linux, Mac OS, and Docker. Okay, so it's like a does it provide HTML so it's for websites.
You can do websites, single page applications, multi-page applications, plus APIs.
Oh, okay. So this is our app here. We're logged in as
Ben kaçtım,
Bible
görüşürüz. See you later.
All right, see you around. See you, human. That's pretty neat to know. I'll have to look into that sometime. So we are, showing people's messages. We are looking, do we have the request table in here? We are using Bible Breeze, BB. Daily verses. Do we have, oh, we do, look at her. Prayer request heart. Oh, we actually called it a prayer request heart table. Remember I said that it should be instead of likes, it should be heart. So I did change it over to prayer request heart table. Let's look at the structure of it. Prayer request heart ID, heart date, prayer request ID, and the member ID. The person who prayed, the person who gave the heart, what the heart went to, the date that the heart was made, and the unique ID of that heart. That's what this is. This is a cross table. So this table contains like information for the prayer table, which is this right here, prayer request table. Prayer request table has all this information in it. Now what do we need? We need to pull that information out. But first we need information to pull, don't we? We can't just pull, nothing. So what are we going to do? Well, we're going to make some information. All right, prayer request. We are going to insert prayer request ID. We're going to call it 1. Request full answered? No. Prayer request message. Please. I don't want to actually do a prayer, but this is a prayer request message example. Okay, prayer request date. Now this is going to be Unix time, so we want it to be a Unix time base. So we need to change this from internal to when it goes. Let's see, structure. structure, we wanted to make sure that it prayer request date automatically sets the date. Integer length values, coalition attributes. On update current timestamp. Here we go. Bam. So it'll put the current timestamp. Invalid on update clause for prayer request date. Probably because it needs to be a timestamp. Let's see. Is there a timestamp? Timestamp. Bam. Default current timestamp. Bam. Attributes on update current timestamp. Now we're cooking with Crisco. That is it. All right. So going back to our insert, prayer request ID 1. It is not answered. This is a prayer request example. Current timestamp. Prayer request. Oh, okay. So we're just going to do 1. Now let's do another one. 2. This is a second prayer request example. Current timestamp. All right, and then that's it. And then we save it. Where's my save button? There we go. Go. Insert into, okay, it's going to run this SQL. Yep, looks good to me. No, it's not any good. Why not? Duplicate entry 1 for key prayer request table. Oh, there was already one in there. All right. Yeah. 2. That other one must have saved. I need to delete it. All right. Let's see what we got going on there. Prayer request table. We got 2. This is a prayer. This is a second. Okay. It happened. It went through. Good enough. Good enough. And this is the date it went in. All right. So we got 2 of those. Now, do we want some likes? Yeah, let's give them some likes. Started and prayed. Actually, you know what? Let's stop. Let's not do that. Why do we have a prayer request pray table? Because we have the date it was prayed and who prayed for them. So if you remember on our app here, we had some pictures of people up here. Hello, Hyla. How you doing? Welcome to the show. So these people here, we're going to say these people prayed for this portion right here. So someone actually clicked on and clicked down and held on to this prayer request for 5 seconds. And then they'll pop up as being a person that prayed. So to be able to track these people here, you need a table, and that's what this table does. This table tracks who these are and what they prayed for down here. All right. Now, let's see. Let me answer message 1 quick second. All right, sorry for the delay. Sorry about that. Okay, so we have this table here. We just put information in here. Now we need to get that information into our app, right? So we need some structure. We need some form. We need some way to get it. So to do that, 1 second. One more message. Twitch.tv/. Okay. So to get this information, we go into our code back here. Now we have this designed like ResoCoder says, right? Because how does ResoCoder say we have to build our applications? We need to use DDD, design-driven design.
Domain drive.
Thanks. Domain-driven design. So we have our application up here. We have the presentation, which is all of our front-end work right here. We have the domain, which has our use case entities and models and the initial repository. The repository is what links the domain, the presentation, with the infrastructure down here. So the first thing we want is we would need an entity. To keep things in order. And if you want to know what I'm talking about on the DDD, domain-driven design, and exactly who ResoCoder is, you can go to his site here at resocoder.com. He is an excellent tutor, and for free, he has given you an excellent class that is what I learned how to do this on Flutter. You can go to tutorials, Flutter, domain-driven design, and he just breaks it down here beautifully, how the presentation, the application, domain, and the infrastructure. If you remember, that's just what I was showing you, the presentation. The only thing I did is I put application above presentation because it just made better sense to me. But presentation, application, domain, and infrastructure. DDD. So if you go DDD, what that does is if you make a change up here in presentation, it doesn't affect your infrastructure. If you make a change in infrastructure, it will feed your presentation. You don't have to make a change up here in presentation. So it keeps the code separate. It keeps your back end on a back end, it keeps your front end on a front end, and it allows a domain to talk between the two to transfer that information. So it's very good system. Okay. So first thing we need, I said we are in, what is our app in? Our app is in the daily. Let's see. This is a dashboard. This is the study hall. This is the fellowship. And this is the daily. And then we're going to pray. So we go to, on here we go to, what are we looking for? We're looking for an entity. Lib, domain, entities, daily repo, prayer request. Look, we already built a hot dog. How about that? So what is this? This is a prayer request. So it extends, I go to the table. So what is a prayer request? A prayer request contains a request ID, a bool answered, a message, and the prayer request data. What is prayer request data? Prayer request ID, answered, message. You know what that data is supposed to be, folks? What is that data supposed to be? I bet you know. Bet you know. What did I do wrong here when I made the prayer request entity? That's why it's always good to go back and look at what you've done. Because I just got this set up for this quick little tutorial. So I have a prayer request ID, right? I have a bool answered, right? I have a prayer request message, but what in the world is prayer request data? Well, let's go all the way back to our thing. Should be a prayer request date. I just misspelled it. So what does that mean? It means I get to change it everywhere in this file. But thankfully we have Control F, find, and we're going to say data. We're going to make sure it's capitalized because we don't want lowercase in that. To date. We're going to replace everything. All right. So that should be it. Prayer request date. Prayer request date, prayer request date. Okay, we changed it in everywhere in here. So now we have our entity ready. We have what is going to link our presentation with our infrastructure. Today, we're just going to focus on the API. So we're just focusing on infrastructure, but we need to start with the domain, what's going to link the two, link the infrastructure with the interface. And to do that, you build your entity up. Later, you get into your models and whatnot. So then once you build your entity, you can go into your infrastructure and start using, you really want to bring a model down in here too, so that way you're not reaching up into your entity. For example, let's see, daily repo, daily verse model. So on the app, I have daily verses. Let's see, right here. These are daily verses. So all of these is a daily verse. This is today's daily verse. Wherefore, seeing we also are compassed, this is yesterday's daily verse. Pardon me, I'm not very phone savvy. I do most of my stuff on. So this was a daily verse on the 24th. So I and my Father are one. So based on the daily verse, you have a daily verse entity up here. Daily repo, scripture, which is where we're at, daily verse entity. So your daily verse entity is all outlined here. It contains your verse ID list, entity, all this information. So that links your repo with that links your front end, your presentation, with your back end, your infrastructure. Then you go down into your models. How do you bring it into your infrastructure? Well, you can reach up into your domain. There's nothing to say you can't reach up into the domain and pull your entity all the way down into your infrastructure. However, it's good to have a model down here. That way you can do fancy little things with a model, like from WebJSON, from JSON, from more, which is your drift database, combine lists. So you can do fancy little stuff with your entity down here, because it extends the daily verse entity. So this is all infrastructure specific stuff. So with that in mind, I'm just going to build me a model down here in the infrastructure, just in case I want to do some fancy stuff like from the web, JSON or something. If something just isn't going right and I need to do a little adjustment because of the way the web works or because of the way iOS works, then I can have that feature and ability down here.
It will be nice if it maps the JSON data into the model automatically.
Exactly, and that's what this does right here. From JSON, we'll map it from your JSON file. It will look for this here from the JSON, which is from your API. It'll typecast it into an integer, and it'll turn it into your daily verse total shares, which is part of your model, which is an extension of your entity, which gives your presentation, which is using that entity, access all the way down the tree. I know it's a lot to take in at first, but if you do Reso Coders tutorial, you follow that, and then you come back, you'll say, oh, I understand what he was talking about. That's what he meant. So we're going to go ahead and do that here. We're going to create a model here. Best way to create something is to copy off of something else. So we are going to go to our prayer request that we have correctly in date. We're going to just copy it, and we're going to go down to our model.
Actually, I made an API call today in my application.
You made one?
Yeah.
Okay. What is it? What database are you using? MySQL or PostgreSQL?
There is a website called JSON Placeholder.
Oh yes, yes, I've seen that, where you can just create a random JSON database, right?
There is predefined endpoints. It's fake.
Okay. This right here,
Can you,
this site. JSON
yeah,
placeholder.
just to learn how I can make API call in Flutter.
Okay. Yeah. This is really good. Thank you for this.
I took posts.
Yep. Thank you. Thank you. Oh, you did posts?
Yeah, click. See, you
Ah.
can API call here and you can get that
You can
JSON
get
data.
user ID, title, and body. You know what? I might even use that just so I don't have to write the PHP on this. Thank you so much for that. We are going to use what Cranberry just taught us today, folks. We are going to use JSON placeholder and we are going to use posts. But how do you use posts? How are we going to use posts? Hey, what's up, Caval? How are we going to use posts? Because it's clearly an ID, a user ID, an ID, a title, and a body. We'll look at specifically what they are. That's an integer. That's a number integer. This is a text string. This is a text string. We can use that, but I like English. Let's see. Do we have English anywhere? Nope.
No,
So,
it just doesn't make sense. It's for testing.
oh, it's just for testing. Okay. Well, so do we? What's in comments? Comments has a post ID, ID name, just a little bit more information. We don't need all that information. We just need this. Now, what we're going to do is we're going to take these strings and integers because that's all we care about. We care if it's a string or an integer. We don't care what it says. We don't even care what this says. We just care if it's a string or an integer. And we bring that into our database here with our JSON code. So we copy that. We come down here. Daily repo, we're going to make that scripture, we're going to make a pray, new folder called pray. And in pray, we're going to put a daily prayer request model. Now we are working from the top down, where you can work from the bottom up, but it's easier to start in the middle and then either work up or work down. I'm starting in the middle and working down. So I started in the domain, built my entity. Now I'm going down into the model and building the prayer request model. So I'm just pasting that here.
Actually, there is a principle that says you should start to design your app from the top. I mean, from the UI, because it says you're not gonna need it.
Yeah, there and I agree with that, Cranberry. So folks, listen to Cranberry. What he says with the UI. What I did is I had my front end guy make me this UI. So in theory, I am starting with the UI. This is here and ready for data. Because as Cranberry said, if you don't start with the front end, how are you're just spitting out data. How are you going to know what you're going to be, using? What's your end state? What's your goal going to be? So if you don't even know what your goal is going to be, then all you're doing is playing with information and feeding useless information up to the top. So as Cranberry mentioned, make sure you have at least a wireframe design or something set up on your front end so you can start plugging data in. So the prayer title here, the prayer message. And if you look, you see the front end is asking for a prayer title. Do you see anywhere in here a prayer title? Nope. What does that mean? It means we might need to be adding a prayer title in the future, which is not a big deal. But it's asking for one. All right. So as Cranberry said, make sure to start with something in mind. Start with some type of idea of what you're going to have. And in this case, on our prayer requests, we're going to have community prayer requests up here, what people are requesting. You click on that, you hold it down for 10 seconds. The card appears here, it highlights, you hold it down, you pray for that person's prayer request, and then it turns green, you can pray for the next one. Down here are what you want, down here are your prayer requests that you may have that people will pray for. You click on it and it'll bring it up here. And this is a list of all the people that have prayed for it. And then if your prayer has been answered, you select it as answered, and all your past prayers that have received prayers and have been answered will be down here. So that's our front end. That's what our end state is. That's our goal, what we want to get to. So now we did start at the top, as Cranberry said. Then we went to the entity part to build an entity that can talk to the top. But now I could play with the top. I could use Cranberry's example model to could use Cranberry's JSON to go from the center up, but I'm not going to. I'm a back end guy. I work on the back end. So I'm going to go from the center down. I know what the front end is asking for. So I'm going to let the front end worry about everything. I'm going to give them the entity. I'm going to give them this information. What these guys do with this information is up to them up here. I'm just responsible for getting all the way up to domain and giving this information directly to domain. And then these guys will ask me what they want from there on. Okay, so let's continue on. So prayer request model extends what? The prayer request entity, right? Ooh, this is not good. Always must have written this wrong. Prayer request entity, prayer request entity. Let's change that to prayer request entity. As you'll see, all of my entities end in the word entity. Therefore, I know it's an entity. So this should say prayer request. It's good to, some people, just for naming convention, some people will go prayer request entity. That's called Camelback. I use this method here because I'm a database guy, prayer request entity, but I do use Camelback in here. So we're going to change that. We're going to change Command F. We're going to change prayer request to prayer request entity. And it could have been the front end guy that did all this. And because I don't remember doing this, so it was probably my front end guy that did this because I would have caught that prayer request entity. So we have that set. What's up, Vannon? How you doing, buddy? We are talking about backends, and we're building a backend JSON support for just a table here. So now we go back. We want to extend prayer request entity. If we click that, it'll automatically bring our package in here. And what is this? Unused directive. Let's get rid of unused directives. So now we have the prayer request entity model here. How do you make a model? What does a model look like? If you don't know, copy one. Let's look at one. Let's look at our daily verse model. So our daily verse model has everything that's required here, and then it has the information from your entity here. So your entity comes down, your entity is available here, daily verse ID. It's available from the entity, and it is required. An internal is required. So this is an internal, this is a string. So this is what we're looking for in a model. We're having our required values here. We're having the super, I forgot the name of it, folks. If someone knows out there, holler what this is called here. The super insert word. What is it?
Doesn't it calls daily verse entities constructor?
Daily verse entity constructor. Thank you so much. Yes. So the daily verse entity constructor is your super right here, which has all of the information, what your daily verse entity is looking for, and you make sure that that is, since it extends the entity, it's going to be required in the model, which is what this is saying right here. This is saying that the method prayer request should have a return type, but doesn't. It says right here required dynamic required, all of this information. So let's go ahead and put like this, required, and then whatever it is. So what is our prayer ID? Our prayer ID is an integer. Prayer request bool answered is also an integer. It may say bool, but it's an integer. It's either a 1 or 0. Prayer request message is a string. And prayer request date is an integer. And then let's go to our entity and let's go to this will work. Let's just take this right here from where it was created under here and I have it twice. Yes, I do. I need to get rid of that and put that. Prayer request bool answered. Prayer request bool answered. Y'all can go back in this video. For those that are just joining, this is being streamed live on Twitch TV. It's being streamed live on Twitch, on YouTube, on Trovo, and a couple other sites, but Twitch TV primarily. So you can go back if you need to see any of this on those channels. Okay, so our model is set. Now this is all of the to map and from map is all of your higher functionality. You're going to map it to and from in your upper domain, in your presentation layer. You're going to be dealing with maps. But in your infrastructure, you deal with JSON. What is JSON? JSON is as Cranberry showed us here earlier. Close that there. As Cranberry showed us earlier, JSON is this right here. It's a structured language that is read by an array, an opening array here, a bracket, opening bracket, a closing bracket, and information in between. And this can be nested. Let's see if we can find a nest. Routes. I'm sure there's a way to do it on here, but I'm not going to play too much time. But just know that these can be nested. So you can take this information here, you can take this, let's say copy it, and you want your body to contain another post, you can paste it right here and it'll be just like that, opening and closing. You'll have, so you can have just multiple layers, multiple nesting of JSON. And it does get pretty deep. I've seen some, another thing that's popular, similar to JSON, is called GraphQL, which is very much similar to this. But this is JSON. This is what you work in on the back end. You reach out and you pull it in this format. So coming back to here, we don't need all of this. We have our prayer request model. We don't need the copy width. We don't need the from map. We do need from JSON. All right. So what does a model look like? How's it getting from web JSON? From JSON is going to be of a tag dynamic in JSON. So daily verse ID equals JSON daily verse ID, and then it does the typecasting here. Now this is where you have to have everything match up. You know, I know I don't want to confuse everyone, so while I would be able to use this here, I'm not going to use this website for bringing in JSON because it would kind of confuse people in what I'm about to explain. So the reason you start on infrastructure with writing out your data like this is so that everything is the same throughout your entire code. So when you build your database is going to look like this. It's going to look prayer underscore request underscore like underscore ID. all lowercase. Everything is going to match this way. The reason you do it this way is so when you get to this one part of your code, your JSON, you can bring it in and you know it's going to be exactly like you typed it. So you're not guessing what, see daily verse total comments as integer. Now, let's see, let's find a message. Verse ID list, it's a string. So if I wanted a string from a JSON, I would come here and I would look for a name. I'd ask for name and name would give me this. So see, this is name, this is JSON, right? These are the IDs. Everything before this colon is the ID of that JSON. So post ID, ID, name, email, and body. These are the values of that. This is the key, this is the value. Key, value, key, value, key. So this is the value of this key. So you take the key, in this case name, and you would use it in your code right here. So if I put name right here instead of verse ID list, it would look for JSON that has the word name in it, and then it would fill verse ID list with whatever value that key holds. So it would fill verse ID list name, it would fill it with, what would it fill it with? It would fill it with this value right here. So that's why it's important to have your name scheme the same throughout your entire code. That's why it's important, as Cranberry mentioned earlier, start with what you want. If you start with what you want, you know with what you want on the front end. If your front end guys have already built it, you know you're going to need prayer request text. So you might call it prayer underscore request text. You know you're going to need to see who's prayed for that. But you know you're not going to save entire profiles, you know, pictures and names and contacts. You're not going to save the whole profile under that prayer request. Instead, you're going to save the member's profile ID number. And then you're going to build a function up in the front end which will take that profile ID number and display it as that user's profile. So you're going to need to save in your database something like member ID, member ID. You don't need that up here for the prayer request table because you have a prayer request ID. Prayer request ID has a prayer request likes table that has a member ID. Prayer request pray table, so the member ID is all here. Do you need a member ID and prayer request table? Let's see. This is the actual prayer request. You have the ID of it. You know what? You do need a prayer request, so it is missing member ID. And you're going to find these things as you're building, as you're going, as you're coding. You're going to find things and that's why it's so good to have it written down, because then you can just go there and say, okay, oops, highlight this, oops, highlight this, and then you can come back to it off camera and you can fix it.
Yeah.
All
I
right.
also forgot some properties.
You do the same thing?
Yeah, I forgot and then I realized I did something wrong.
Yeah. Hey, I can't name the number of times y'all are seeing it. You're seeing it right now in person. Let me see how long I've been streaming real quick. I don't want to stream all day long. I've been streaming for 54 minutes, so I've got about 6 more minutes and then I'm off the air. So I'm going to leave with just explaining the JSON information here. We're going to pull it. So what is a factory? Cranberry, what's a factory?
I don't know.
Okay, fair enough. So when you call this model anywhere, let's see, daily verse model. Let's find out where daily verse model is called. Daily verse model. It is called in the DAO, the database, insert whatever DAO stands for. Final model equals PB remote database. Okay. Unless there's something let's say that's daily verse model, that's daily verse model, that's daily verse model. Okay. When daily verse model gets first called, daily model equals daily verse model from JSON. When it gets first called as it is called here, a factory will always execute first. So a factory gives it factory will execute as a function, not first, but a factory gives it functionality. So think of it as like a statement. This is probably really wrong, but think of it as a void, integer, a string. A factory gives you access to whatever you are calling. So from JSON, from more, combine lists. So it gives you the ability to call your model and do something with your model. So in this case, we're going to want to get data. We're going to have our daily verse model, and we want to get data from JSON. We want to get data from a JSON string.
Mm-hmm.
So to do that, here in our BB remote database, which is down in our infrastructure, here in our remote database, we actually do the call in our get daily verse entity by date. We do the call daily verse model from WebJSON result as list. And we get this result here from our API call, which is that website you were talking about, Cranberry.
Mm-hmm.
This is your API call here. So tomorrow what I'd like to do is discuss API building, how to bring the API, this part right here, how to build this. But today we're just going to complete the model, and which is what is just step 5. So we've done the repository.
Actually, as I have said earlier, I made an API call and I actually used the thing you said, factory, and I have displayed the data.
So you used the factory and you displayed it?
Yeah.
And that's what I'm going over today is doing that same thing. Well, I'm kind of slow. I'm over explaining some things just for anybody that might not know. You know, part of me, if this is well above your knowledge level, you know, this is an open discussion, open meeting, so it's for everybody. You might get a little something.
Yeah.
So we started with the domain. We built an entity. We built the prayer request entity. We then went down. We acknowledged that we need to start with a UI framework. We acknowledge we need to start with something on the front end. We need to have some idea of what we want in the back end. You know, you just don't want to just start willy-nilly. Then we went from the domain entity, we went down to the infrastructure. Now we did not touch on repositories. Let's touch on that real quick. Repository, we said we were in the daily repo, right? Why are we in the daily repo? Because this is broken down into, let's see if I can go back. Nope, doesn't look like it. Oh, there we go. This is broken down into, this is the dashboard. This is the study hall. This is the fellowship. And this is the daily. So daily scripture, daily prayer, daily thankfulness, and daily news, right? So,
Right.
And then we have the Bible right here, which is currently not applicable. It does work, but it's just can't be turned on right now. So far, the only repositories we have is the authorization repository, Bible repository for this button, the daily repository, which is this right here, and a member repository, which holds our member information up here. These guys, this guy right here, it holds that this is who I am. So the member repository, it also handles a little bit, it talks a little to your auth repo. So all I have right now is a daily repo. I haven't even started on these other repos. I'm only working on the daily repo. So what are we doing? What are we trying to give them? What are these guys asking for? This guy is asking for a card. He wants a request, a prayer request card. He wants a prayer request card. So we need to get the prayer request card data, right? So we got
Yes.
get daily comment by daily verse ID, post like daily comment, post like daily comment, post like daily verse, post. So we got a bunch of posting. We got, and then we got one get daily verse by date. And then we have some little notes we left ourselves here. Simple as this. All we're doing is just providing. This is daily verse repo. Oh, sorry, I forgot something in the domain. Very important. After you leave, your use case is for up there. After you leave your entity, you go down to your repository. Your repository, your daily repo number 3. Down here, you have your abstract class, which is number 3, repository, daily repo domain. This is an abstract. This abstract is nothing more than saying is a contract, as Riso calls it. It's a contract between your upper area, your domain, and your presentation with your infrastructure. It says, I want this functionality. I want this functionality for my presentation. So we want to make a functionality, and this may change in the future. We're going to call it future either. And to understand what this either means and all, you will need to watch Riso Coder's DDD code example, and then come back here. This is called a union, and it's using darts. It's an either union, either failure, or we're going to return a what? We're going to turn a prayer request entity.
Does that have interfaces?
Yes, this is the interface. This is the interface for this right here. What Cranberry was just asking for those not sure is he's saying this here is a contract with the domain, the lower part. You must be a front-end designer, are you, Cranberry?
No,
No,
not that interface.
not
I
that.
mean, when we code in C#, we have abstract class, but we also have something called interface.
Huh.
It's like abstract class,
Mm-hmm.
but different.
No. Yeah, no, this is not that then. I thought you were meaning is this contract for the interface? But yes, this contract is for the interface, but as far as C#, this has no functionality. Does this need to even exist? Yeah, it does. Why does it need to exist? Because this is DDD. And you need this here to know that you're going to have this contract available up here. So your code up in the infrastructure is going to call this right here. It's not going to, or your code in the presentation, excuse me, is going to call this right here. It's not going to call all the way down. So let's at least get to number 5 today. I'm already running a little over time. Those that were looking for an hour video, my apologies. We should be cleaning up here shortly. Okay, so we're going to request prayer entity, and we want this card. So we're going to call it get prayer request card. How are we going to get it? Are we just going to randomly get one? Well, we know we're going to be on someone's prayer page, so we can get it by member ID. We could get it by prayer ID. It just depends on what they click on. So we're going to have multiple, just like this, get daily verse by date, post daily comment. We're going to have multiple, like get daily verse by date. You have functionality up in the upper domain, which actually, now that I see it, it shouldn't be up there. But you want to get daily verse by kind, so prayer request, community prayer request, personal prayer request, received prayer request. So you have that information here by kind. We're going to call this by card. And what is this card here? This card is a prayer request card by request ID. And then we want required, curly brackets, required integer request prayer request ID. There we go. So now this is a contract for interface providing linkage between presentation and interface. That's what the domain does. It provides linkage between the presentation and interface. So now that we have this abstract class, you have to implement it. So we are on number 3, the repository. So now we step down into the infrastructure. Now we're going to go down into, where's my favorite man, Riso? Now we're going to go into so we were right here on entities, on objects. Use cases was up here, entities right here. We just created the either or. Your failure can also be your abstract class. Your abstract class right here. Now we are going down into repositories down here to the infrastructure. We're going right here. So repository is part of domain and infrastructure. You have your repository abstract class up here. You implement it into the infrastructure. That's how all of this talks. So we go back over here, our infrastructure, onto our repository, daily repo. Why is it red? It's red because we are missing an implementation of the daily repo domain get prayer request by request ID. So what are we going to do? Quick fix it. We're going to create that missing override, which puts it where is it? Where'd it go? Right here. Prayer request card ID. So here's the implementation. It overrides it. You know what the implementation? Why? Because it implements daily repo. Daily repo infrastructure implements daily repo domain. So the infrastructure implements the domain. Daily repo infrastructure implements daily repo domain. We're going to pass over through get it. Again, you need to watch ResoCoder to understand this. We're going to pass the API, which is our external database, and we're going to pass the ability to talk to our internal database. So external, internal. Why? Because we have internally, we have put this table here as well that matches our external table. We put it here for cached use. In case people are offline, they can still look at their prayers and whatnot. They can still look at information that is cached locally in their local database. So that's why it is also locally. I'm trying to get back. Let's just click here. All right. So now we implemented it here. Now we can go. Yeah, I skipped all of that. Now we can go into our model, daily repo, prayer request model, extends prayer request entity. What is wrong? Name of a constructor must match the name of the enclosing class. So this is just saying we need a constructor. So we need an example. We need an example. Let me close a bunch of this up. From JSON, right here. This here is the constructor. This normally should be at top. That's why I like putting it anyway. I don't know why I put it down I must have had it up there and then put the from web JSON afterwards. Ooh, what did I do? Oh, took the closing bracket off. That's what I did. All right. Trying to explain and work here is a little difficult. In any case, we need to implement a model, a daily or a prayer request model right here. So let's go ahead and implement that. Prayer, const prayer request, and that's what this is, model. Sorry about that. Okay. So it was saying that, so if we take that off, it's saying that name of a constructor must match the name of the enclosing. This is the prayer request model. This needs to implement the prayer request model. That's what that was. Now we need to have something from JSON. And I like to copy things. So from JSON. From JSON forms a model. This is what type of model? This is a prayer request model from JSON. Now this here is what the JSON is actually is. It's a map of a string and a dynamic. What is that? What is a map? So a map is this. In Dart, this is a map. All right, that's a map. That's a map. There's also map, which is a map. There's also dot map, you know. But for this purposes, for JSON purposes, we're going to go with curly brackets. That's a map. Now we're going to have a string. That string is our key. Now it has to be a string. Can it be a map number? No. This code would not work because it's looking for a map, which is between our curly brackets. It's looking for a string. So a number won't work there. And then what? Then it's looking for whatever you want to put there. It can be ooh la la. It can be that. It can be 1, 2, 3, 4, 5, 6. It can be that. It can be some rather long message. It could be that. Whatever you want it to be. That's your map right there. Does this look familiar? Opening bracket, key, that, and value. What is this right here? What are we looking at right here? We are looking at, oh, I already closed it. We are looking at this right here. We are looking at what Cranberry showed us earlier. We are looking at this. We're looking at opening. We're looking at a map. We're looking at a string, even though it returns an integer, even though it returns a number, this can be whatever it wants to be because it's dynamic. This has to be a string. So this has to be a string. This can be whatever it wants to be. So that's what this code is doing here. This code is looking for a string dynamic, and we're going to call it JSON. Okay. So then we start our mapping. Let's just do this here. I like copy and pasting. Once you get familiar with it, you'll be able to do similar. So we're going to change prayer request ID equals JSON. That. Now what is different from this and this? This is where you'll see a big change. This is Camelback. Will this work? This is the key, right? Will this,
Yeah.
will this key work? It will not work. Why will it not work? Because it is looking for this prayer underscore request underscore ID. It is not looking for prayer high case prayer request ID. So right here is where the magic happens. Right here in this from JSON is where you take it from an external source, your API, and turn it into your code. Your code then turns it into a model, which is what your factory does, turns it into a model. Your model extends an entity which gives you access to the entity up here, and your presentation uses that entity. That's how it all reaches down. The magic of everything happens right here in your infrastructure model. Now, if this changes, here, any of this changes, it's going to affect everything. Remember I said what happens down here doesn't affect up here? Well, this building portion does. However, once we get down, if I want to change the source of this, let's say I move servers and I get a new database set up and I want to use PostgreSQL. All I have to do is make sure it matches this scheme and then change in the back end where I'm connecting to, and that's it. Just to give you a visualization of what I'm talking about.
Nice.
If I want to change up here, if suddenly up here I get a new, I lose hosting and I need a new host, and that new host only provides PostgreSQL that's all I can use for my API, then all I have to do is come down here and change my database. I don't have to change any of this up here. None of this has to change. All I have to do is change the database and make sure the database conforms to this right here. Just make sure the database provides this information. The database provides this information in this format. None of this has to change. Same for the API call. And this is internal database. API is your external database, your PostgreSQL, MySQL, Amazon, Oz, Cloud, Firestore, whatever. Your external API is over here. As long as it feeds the correct format, that's all you need. Now, if you do need to change the format, again, where does magic happen? The magic happens right here in your model. So if it just cannot give you the format in this and you have to change it, this is where you change it at. So we have prayer request ID. Then we have prayer request full answered equals JSON prayer request full answered. And if you notice, the Camelback prayer request full answered matches the underscores. It's once you get used to the naming conventions and using your API interface and writing backend, it just becomes second nature. When you look at prayer request full answered, you also see prayer underscore lowercase request full answered. The nice thing about Drift that I was talking about earlier is it does this for you too. It looks at Camelback like this, and it automatically turns it into lowercase underscore just like that, and it links these values together based on underscore if it's Camelback. That's Drift. Okay, then we have prayer request full answered is done. Now we did something down here. We did typecasting. So we need to typecast here, prayer request ID. What is it? If we don't know what it is, we just come up here. It's an integer. Now, let's say we messed this up. Let's say we called it a string. What would happen? Well, this would be wrong. Why? Because as Cranberry said earlier, this is the entity's constructor, super constructor. This belongs to the entity, and we're saying this is going to extend the entity, so we need to at least match what the entity is. So we need to match the prayer request ID, and we're calling it a string, but the prayer request ID says the argument type string can't be assigned. The argument type string can't be assigned to the parameter type integer. So we know this is supposed to be an integer. So if this is supposed to be an integer, then this is going to be an integer. It's integer. It'll all correct once we get down to the bottom. Let's see, final prayer request ID as integer, final prayer request equals. So this factory, when you call a factory, it executes. It's when you say prayer request model from JSON, it executes everything in here. So it's going to pull up your prayer request ID, your prayer request from your JSON. Your JSON, it's going to get from map JSON decode as, let's go to a daily verse model. From JSON, here we go. So it's going to create all of this here. It's going to pull all this. It's going to receive this JSON data. It's going to receive JSON as a map string dynamic. So it's going to receive web data or API data. It's going to receive API data. It's going to take that API data. It's going to create an integer daily verse, and it's going to create it based off of the daily verse ID as an integer. It's going to create a string. It's going to base it off this string. So it's going to take this ID, the string ID, string ID, string ID, string ID, and it's going to create the dynamic value, integer, string, list. Even lists are dynamic. So it can be a list. It can be anything you want. It can be a string. It can be a list. And in this case, it's a list. Is what JSON is passing. It's passing it as a list. So then once it pulls all this information and casts that information into your code, once this magic happens right here, when you called it, it returns this model. Bam. It returns this model here, and this model then can be used throughout your code because this model conforms to your daily verse entity, which is all the way up here near your presentation. It's all the way in your upper domain where it can be used by your presentation. All this magic happened back here just by using one entity. By calling one entity, all this magic back here is happening. All right, so let's finish up. Let's finish this up. We're going to prayer request message, final prayer request message equals JSON prayer request message. I have a microphone in front of my mouth, which is why I'm kind of not using my keys as normal, because there's a microphone here. And final, I think this is it, final prayer request, not final prayer request date equals JSON that is passed to us. JSON is just dynamic. It can be anything. It's a string and dynamic. So the string is right here. The string is prayer request date is our ID from our JSON. And the dynamic, we need to make sure to turn that into statement. And the dynamic is right here. And then what do we do with all of this? See, this is, if it's a list, it does a from map JSON decode. It does a little bit extra. If it's a list, prayer request from map JSON decode source as map string. If it has to deal with a list. In this case, verse entity, again, it was a verse ID. It's a verse ID, two-string verse entity. We made it a verse entity, a list right here. We didn't actually use a string if you look. We didn't use a dynamic function. Load it blank first, fill when needed. So we loaded it blank. We didn't use what was available in our dynamic. You don't have to use what's in there. And I'm going to undo this. You don't have to use the string and the dynamic. You just have to make sure you account for it. So if it's in there, it's going to be going by this list. So if it's in there, it's going to be going based off of this here. 1, 2, 3, 4, 5. It's going to accept 5, and my music is ended. That means it's about time to end this show, folks, and we're almost done. So restart my music. So we got a little happy music going. And let's finish this up because this is going almost an hour and a half. All right, so now we are going to go ahead and return all of this information and call this a day. Don't need any of this here. We're just going to lose that there. Return prayer request model. And look, I like this. This is why I like VS Code and Dart extension. Watch this. You type in prayer request model, hit enter. Right. It does everything for you. It puts all that nice jazz in there. Now, prayer request ID, prayer request full answer, prayer request. Why do we have some of them red, some of them not? Let's see. Type dynamic can't be assigned to. Oh, as I was saying, we need to assign that. That's what you get if you do not do your typecasting. You're just calling this a dynamic. So you're going to be using it as dynamic everywhere in your code, which is okay. You don't want to do it. You don't want to use dynamic everywhere in your code because then you don't know how to treat it. You don't know whether it's a string. You can use a string in here or you can use a number here. You don't know how to treat it. So you want to cast it right here where that magic happens. You're going to cast this as an integer. You're going to cast this as a string. And you're going to cast this as an integer. Why do we know all of that's there? Because that's what our entity is looking for. How do we make sure we abide by our entity? Because we extend it and it supersedes right here. It supersedes our prayer request model by providing us what it's looking for as an integer, string, and integer. Folks, that is it. We have made it down to step 5. What do you do when you complete something, when you are at a stopping point? What do? You commit your code.
Of course.
What did we do today? We created JSON for prayer entity. Then description, modified prayer, what was it called? Prayer request to prayer request entity, just in case we're putting this note in there for all the developers in case the front-end guy was actually going to be has already started code and hasn't committed it, and they use prayer request, and then when they go to commit it, it's not working. They'll be able to see the prayer request was changed to prayer request entity. Shouldn't happen though, because we do a lot of polls. We keep in contact. That's why you always push whenever you do an update. Do not push bad code. If it cannot compile, like if I cannot hit reload on this, oops, I just hit stop, oops. If I cannot compile this and it starts, don't push it because you're going to mess up everyone else's code. So we did that. We turned it into a prayer request entity. Then we just hopped down to number 4. We created abstract and implemented get prayer request card by request ID, I think it's called, which is all self-explanatory. It might be long. That might be a really long statement, but do you understand what it's doing? absolutely. You understand it's going to be asking for a prayer request card by the prayer request ID. Pretty simple. So make it as long as you want. There's no rule to say it can't be long and explanatory. Riso goes over that in his own tutorial. Again, visit Riso Coder. Here we go. It's just now piling. It's just now starting up. And then lastly, we went into 4. Lastly, we went into 5. We went into and built and as you see, everything's here. It did not change anything. The back end is the back end. The front end is front end. Nothing changed at all because I'm only working in the back end. And then lastly, we went into number 5, created extension of prayer request entity into model and made a from JSON. That is everything we did today. And if we wanted to number it, how would we number it? We'd put it as domain 3 created to prayer entity, created abstract. This is domain 4, I think it is. Nope, this is domain 2. No, that's 3. This is infrastructure 4. No, domain 4. Create a prayer request. I'm confusing myself. This is implemented prayer request. This is infrastructure 5. And this is the model is infrastructure 5. So let's go back one. Infrastructure 5, infrastructure 4, prayer domain 3, and this is 2. So entity is 2, our abstract is 3, implemented the abstract 4, and requested a model 5. Is that what we did? Let's see, just to be safe before we push it, let's look in our lib. C domain, entities 2, yes. Repository 3, abstract, yes. Infrastructure 4, repository, implemented it right there, yes. And 5, daily repo, prayer request model. Everything is right and good, and we commit it to main because we are good coders, and we make sure to keep our code short and simple and descriptions extensive and long. And while that pushes, I bid you all a farewell today. Thank you for watching. Make sure to like, subscribe, follow on Twitch, like and subscribe on YouTube. Stop by flutter.dev anytime and watch the show live daily around this time, sometimes usually in the morning, Monday through Friday. Click on or visit flutter.dev/community and visit the Discord channel.